Welcome to Ask and Learn.
All right, so here we want to prove that n log n is going to be big O log n factorial. Okay, so we will just start by setting k equal to 2 and letting our n be greater than k. And we're going to use definition of the factorial, right, which is, of course, n times n minus 1 times n minus 2 times everything all the way down to 1, right? So the absolute value then of log n factorial is equal to the log, so it's positive regardless of n times n minus 1, so on, all the way down to 1. Okay, but we know that we have this little rule, right, that the log of a product is equal to the sum of the logs. So we're going to use that little rule to turn this into the log of n plus the log of n minus 1 plus all the way down to log 1. All right, but this must be greater than or equal to log n plus log n minus 1 plus all the way just down to log of n over 2, right? So this is like half of the list, roughly. Okay. And that must be less than or equal to log of n over 2 plus log of n over 2, so on and so forth. Plus log of n over 2. Well, great. So we can combine these then, right? We'll get that. I mean, this expression then is going to be equal to n over 2 log n over 2. So we have another little trick here, right? So it turns out that log of n over 2 is actually greater than 1/2 of log n for n greater than 4. Okay, so we get that this is then greater than or equal to n over 4 log n, which is equal to 1/4 absolute value of n times log n. Okay, so therefore, we get that the absolute value of n log n is less than or equal to this absolute value of log n factorial when n is greater than or equal to k, right? Or when n is greater than or equal to k equals 2 here, and also when c is equal to 1/4. And I just misled you. We have here, we changed it to k and the final step being equal to 4, right? So at C as 1/4 and k equal to 4, we then get that n log n is indeed big O of log n factorial.